Good afternoon and welcome. There are an awful lot of people in the audience today. It's good to see so many people excited to talk about touch and multi-touch. It's also a little daunting. I'm Reed Townsend. I am a program manager in Windows and user interface platforms. I work mostly on touch and multi-touch. My friend Anson will be co-presenting with me.
Yeah, and I'm program manager on WPF, and I'm responsible for the touch feature on WPF.
Okay. So multi-touch is here. And if you've been paying attention at PDC, it's been all over the place at PDC too. The keynote yesterday, the Win 7 keynote, featured multi-touch. If you've swung by the pavilion, you've probably seen our booth showing off Win 7 and some of the applications. We have some great partner demos there too. Hands-on lab. I saw a lot of you folks at the hands-on lab. It was great to see people getting their hands dirty, doing a little bit of coding. And even today in the lunch line, I overheard somebody talking with their friend. They were raving about some of the demos they'd seen. That's really great. It makes me feel all warm and fuzzy. On the hardware front, there are multi-touch capable machines in market today, and there will be much more coming with Win 7 launch. Multi-touch also appears in a broad variety of form factors, everything from little tiny mobile phones to laptops to PCs to all-in-one PCs like the HP TouchSmart here to Surface units. On the software side, Win 7 itself will have a really great set of multi-touch features. We, as I mentioned before, have some really great demos and applications from our partners here at PDC. We'll be talking about the touch platform as well. This is the intent of this talk. If anybody is suddenly realizing they're in the wrong room, it's okay. And the upcoming .NET 4.0 release will also integrate with WPF some really cool multi-touch functionality. And from the consumer point of view, people are really excited about multi-touch. Our user research, usability studies, focus groups, everything tells us that the users are really thrilled with multi-touch. Even better, after they've had a chance to use a touch or multi-touch device, they're even more excited about it, which is something I always like to see. And multi-touch opens up a lot of new scenarios, places that you traditionally can't use a PC. You know, it's hard to use a keyboard or a mouse, a mobile scenario, for example. You know, you're working on the factory floor or something like that. Touch can excel in those places. It's also opening new opportunities on the user experience side. There's lots of new UI paradigms that can be explored, and I don't think we've really scratched the surface yet of what really great touch UI looks like. So, enough chat. Let's do a quick demo. The demo's broken up into two halves. The first is covers some of the Windows 7 multi-touch features, not all of them, and then it will end up with a touch-optimized application. It does a really great job of showing what, if you built an app from the ground up designed with touch in mind, what it would look like. So, let's switch here. If you guys can see this, this is an HP TouchSmart that we've kind of lied down on its side here. Touch really demos best when you can see the person's hands and so forth, and I apologize, we can't have you all crowd up around the stage here. So we're trying our best, and it only captures about a third of the screen, so I apologize for that. We've tried to size the window so you can see everything. But if something's not clear, please just yell, and I'll show you. So when people think about multi-touch, one of the first things they think about are multi-touch gestures. Panning, zooming, rotation, you've seen these in a lot of places. We've integrated these throughout the OS. This is everybody's favorite command prompt. You know, this notepad and WinDebug are all you need to develop, right? We've hooked up panning here. Things like two-finger panning you're probably familiar with. We also support one-finger panning or single-finger panning, as we call it. We've added inertia to pan, so you can scroll and then stop your list. And we also have some feedback when you get to the end of a list. The window bounces, or if you try and pan against it, it resists and then will snap back. This lets you know if you've reached the end of your content. It's nice visual feedback, and these sorts of things are really key to making gestures and the touch experience feel natural and intuitive for users. In terms of something like Zoom, if we open up Photo Viewer here, and I want to take a closer look at this frog's giant eyeball, we can zoom in on it, move the photo around. As you'd expect, the sort of standard pinch and stretch gestures work. Also gestures like flicks, which we introduced in Vista, continue to work and are a very handy way for navigating photos and other content. For something like rotate, if I don't want this frog to be hanging off the ceiling, but instead to be right side up, you can easily rotate your images. Beyond gestures, there are multi-touch functionality. There's multi-touch functionality built into other applications in the OS. If I launch Paint here, I think most people saw that Paint got the ribbon. How do people feel about that? Is that 2 thumbs up? All right. Paint also supports multi-touch now. And you can't quite see the brush menu, but there's also a series of artistic brushes, things like chalk, charcoal, that sort of thing. If we open up like the chalk, I can ink or draw and paint with multiple fingers, which is nice. So we've updated some existing apps to add multi-touch support where it makes sense. And then there are features that weren't necessarily originally designed for multi-touch, but that work very well with it. Has everybody seen the window arranging demos where you can do things like drag the windows to the left and they snap left, and drag it to the right and snaps right? These work very well with touch. I hope that this demo as well. I hope you can see the edge of the screen. There we go. But I can drag the window up. And it's very easy with touch to get it to the side of the screen, and then it will maximize or go to the sides and so forth. So this is a sort of first peek at some of the multi-touch functionality in Win 7 itself. Let's launch an app. Our friends in the Surface team helped us write this. It's built on top of our platform. And it's a really great example of a touch-optimized app, as we like to call it, something that was built from the ground up with touch in mind. Let's give it a second. Our network here is not blazingly fast. It needs to pull down some data from the virtual servers. You can also see this in the pavilion. I think many of you have seen this if you've stopped by, but feel free to swing by the pavilion afterwards or even come up here and you can play with the machine itself. So we have a globe here, and you can spin the globe as you would expect. If we want to, let's go find the Space Needle, for example. We can use the sort of standard manipulations that you would expect to be able to dig through this content. And we're looking for South Lake Union, over by the Key Arena, Pacific Science Center, and the Space Needle. And when this gets even more interesting is let's start turning on things like 3D models. Let's adjust our view a little bit. It'll take a little while for some of this stuff to come down over the network. And we'll change our camera view as well. Let me pull this control into view because I don't think you can see it. We have a little control here that lets you add things like 3D elevation and 3D models, as well as change the viewing angle. It doesn't look like the Space Needle's come in quite yet. Oh, there it is. Perfect. But we can do things. Sorry, let me pan that more into view for you. We can zoom in on it. We can do a little flyby, rotate the view around the Space Needle. And then let's go take a look for downtown. We can go zoom in on downtown itself, look at the Columbia Tower, and various other things. This is a really great example of a kind of application that would be very hard to use with the keyboard or the mouse. These sorts of flying through 3D space, you need something like an Xbox controller or some other input method other than just the traditional keyboard and mouse. It's very natural. Everybody gets this the first time they walk up to it. They understand how to manipulate the view and how to travel around through it. So we think this is a really great example of a touch-optimized app, as I was saying before. Okay. So that was the introduction. We're going to move on quickly and talk about some of the touch scenarios, places where touch makes sense in your application. Then talk about our good, better, best model. For the places that make sense in your app, where do you want to invest? And there's various levels. And then we'll talk about the developer roadmap. So if you're a native developer, if you're a WPF developer managed, which sets of APIs are interesting. Jump into some details about those APIs. And then we'll wrap up with some quick topics, things like UX guidelines if you are building a touch app, things you should think about from the user experience point of view. And then if you are so inspired after this talk that you want to go run out that door and get started on your app, where do you get hardware, where do you get the drivers, the SDK, that sort of thing. And then we'll wrap up with questions and so forth. So what did we do in Windows 7 when we were thinking about adding touch? We pulled back a little bit and thought a lot about the scenarios that make sense for touch. Something that continually boiled up to the surface was content consumption. Content consumption versus content creation is something that tends to be very good for touch. Viewing photos, surfing through the web, navigating through email, that sort of thing, triaging stuff in your inbox. These things are very easy with touch. You wouldn't, on the flip side, write your thesis on a virtual keyboard and tap it out. You get a real keyboard out for this. No input method is great for every task, and touch is definitely biased towards sort of quick input, transactional kinds of things. Media scenarios also work really well. This ties in nicely to content consumption. We're showing photos, being able to flick through photos, fix rotation, zoom in on interesting points. Other, things like music, large controls, if you have a large play button or something like that, these are all very easy to use with touch. And mobile scenarios, like I was saying before, mobile scenarios tend to be places where the keyboard and mouse are not traditionally particularly useful, but touch can work really well. So we looked at these scenarios and boiled them down, and they basically led to 4 large areas of investment. First is developer platform, what we're going to be talking about today. Some UI enhancements. You've seen some of these, things like jump lists and some of the stuff in the new taskbar. A lot of these are enhanced to work very well with touch. For example, you can drag the jump lists just out of an icon on the taskbar using touch. Gestures, we've talked a little about this, but we'll talk about it some more. And then we have a set of applications that are going to be very focused on touch, and you'll get more details about those later. So we recommend something similar when you're thinking about adding touch to your app. Basically, back up, think about what scenarios benefit most from touch. Again, content consumption, media and entertainment sorts of things, mobile scenarios, these are ones that really ring true. So if your app does 10 different things, not necessarily all of them need to be touch enabled, but there's some set of them that do make sense to support touch for use with touch. And then once you've figured out where it makes sense in your app or your applications to invest in touch, you should think about how much you need to invest. So in the good, better, best model, good is sort of what you get for free. Things like zooming and panning, we can do a reasonable job in an app that isn't even multi-touch aware of providing legacy support for these. If you have common control scroll bars, for example, we can support panning in that area, in that text box or whatever. If you respond to something like control scroll wheel and that's hooked up to Zoom, we can drive Zoom for you in your application when the user zooms. You may want to consider some UX tweaks. I'd throw a little shout out for the Windows UX guide. That is a great place to go. It has a whole section on touch now, and you can read about small changes that you may want to make to support easier usage with touch. In the better bucket, it's mostly about adding gesture support to your app. So if you have an existing app and it already supports things like zoom and pan, you may want to hook that functionality up instead of, like IE has a little slider in the bottom that lets you change the zoom level. Wouldn't it be great if you could just go in and zoom in IE? Sure. So they went and they added support for our gesture notifications and hooked it up to their existing Zoom functionality. These are sort of targeted things that you can do to make the experience a little better. And then in the best bucket, these are really the touch-optimized apps, the things that you can't do with mouse and keyboard, something that's designed from the ground up to support touch.
So we heard a lot of feedback from developers that you want a consistent roadmap for development, for touch development on Windows. So today, if you went to the Surface session yesterday, they announced the availability of their SDK, and they've done a really good job on kind of showing the types of stuff that you can do on a touch device and the types of APIs and the changes into the platform that to support really touch-optimized experience. Surface is built on WPF 3.5. They've extended a number of WPF controls as well as added their own set of Surface-specific controls. And let's fast forward to Windows 7 release. So at this time, Windows 7 is shipping with WPF 3.5 SP1. But you have opportunity to make use of all the Windows 7 APIs through COM interop and pinvoke. And that story is true for WPF and Windows Forms applications. With your native applications, of course, you have all the natural support that comes with Windows 7. But that's not really a very good story, and we really want to kind of put together a platform that really addresses kind of the touch applications that can go from like Windows over to Surface. So when WPF4 is shipped later next year, we will also have a Surface SDK, the next version of Surface SDK that will also be built on top of WPF 4.0. We are adding touch infrastructure directly into WPF 4, and we intend to share that infrastructure with Surface. So on Windows 7, touch input will be coming through the Windows 7 driver model, and on a Surface device, we'll be able to make use of the vision system and provide all the extended capability that the Surface Vision system has. And we've been working very closely with them to figure out what sort of Surface controls actually make sense to go into the bigger platform available to everybody developing touch on WPF4. So we intend to bring a set of touch enhancements to our existing controls, as well as some new touch-specific controls to WPF4. And Surface will continue to build on top of WPF to provide Surface-specific functionality. So as Reed mentioned earlier, as a developer, you really have a choice on the type of investment you want to make in order to support touch. And we have this good, better, and best model. And I'll just quickly go through the types of APIs and types of work that you would need to adopt in order to adopt different levels of experience for touch. So Reed showed you that if you do nothing at all, your application today that uses the common control, scroll bars, will already get a level of enhancements in Windows 7. WPF 4 will be enhancing the base controls such as scroll viewer to support pan gesture. In 3.5 SP1, because we're not HWin based, we don't get that for free. When we go into the better model of development, it's very easy for you to start adopting the gesture notifications and handle events such as pan, zoom, and scroll, as well as right-click and other types of multi-touch gestures. In Win32, you have the window messaging model that provides that information. In WPF, we'll be building gesture events directly into our base elements. And window forms through pinvoke, as well as overriding the window proc, you'll also be able to get access to the gestures. So if you really want to really maximize the user experience for touch, then you would want to have access to the raw touch data. And again, we provide a set of APIs that's available for you to get at that information. So with Win32, we have the WM touch message, a set of COM-based controls that lets you do manipulation inertia that we'll talk about later, that gives you really good interaction of your objects on screen. In WPF, we have the equivalent. We have touch events, as well as access to the manipulation inertia processors. And in window forms, you can also access this information through the real-time stylus and ink collector classes that's already available today.
Okay. Let's talk about the better bucket for a little bit. Let's do a little bit of demos to demonstrate what we're talking about here. Let me show you XPS Viewer, everybody's favorite document viewing app. Oops. Let me show you XPS Viewer. There we go. Let's get this in your view, too, so you can see what's going on. There we go. OK. XPS Viewer is a good example of an app that took the better approach. They've added support for WM gesture command and respond to gesture notifications that we give them. When somebody does a zoom over their app, they get a notification about that zoom, how far the user is zooming, where they're zooming, things like that. And it lets them build some really great support for zooming and panning. Rotation isn't something that's terribly interesting for XPS Viewer. But you can see that we can pan through the content here, and they support things like inertia and so forth. You can stop the content. All this is really easy. You just get a pan message, and you scroll effectively as you would if somebody was driving your scroll bar. For zoom, you can see that we can zoom in and zoom out, as you'd expect. You can also, as I'm inadvertently showing you here, you can zoom out far enough that they'll actually start changing the views. There's some nice features here. If we zoom back into one of these pages, if you double tap on a page, it changes the view to the fill up the width, effectively. I'm not sure what they actually call it, but it maximizes the width of the content. And then if we zoom back out, imagine, back to the idea of writing your thesis or something. If you were an XPS viewer and you knew that 30 pages in you had some really nice diagram, you could zoom way out in this view where you can see, large amount of content, and then, maybe a couple of pages down you have your document, or your diagram you wanted to see, and you can double tap on that page to go directly to it. So they've done some interesting things with Zoom. It's not just zooming in on text, but they also change the view as you zoom farther out so you can see large numbers of pages. And the panning support is also very solid in this app. Also want to show you, if you've done the hands-on lab, or you've taken a peek at any of the samples that are included with the SDK, we have a little gesture aware app here. And it has this little box in it. And you can pan around in the box, and basically the app responds to gesture notifications and changes the square. So you can do things like rotate, we can zoom and zoom in and out on the box and pan it around and so forth. And we'll look at the code for this in a little bit, but this is one of the samples that's available in the SDK, and I think it's also part of the hands-on lab if you want to play with it. It's just a very simple app that receives gesture notifications and then does something with them in its visualization. So, back to the slides. Gesture command. For the native folks, we have a window message. It was originally designed to be somewhat similar to app command, but it's kind of evolved from there. But it's in some ways it is still similar to app command. It basically gives the application notification that some gesture has occurred: a zoom, a pan, a multi-touch right-click, something like that. And it also has additional information about the gesture that's better than some of the legacy notifications. Instead of just sending H-scroll and V-scroll messages or something like that to drive panning, we added this message because it conveys more information. It tells you where the pan is happening or where the zoom is happening. For example, I could zoom over that frog's eye and not just sort of arbitrarily zoom in the center of the content or the top left or whatever the photo app defaults to. We also tell them how far they're zooming or panning, things like this, information about the gesture itself so you can have really great support. For example, a photo viewer could build something like a live preview of rotation that shows sort of the dotted outline of the photo as the user rotates, because we have this information here. It's not just some sort of pushed command to the app like rotate 90 degrees. Gesture command falls very squarely in the better bucket. It's going beyond sort of what you get for free, but it's still very easy. XPS Viewer, i.e. a lot of the apps in Windows that took advantage of this in Win 7 all found that it was reasonably easy to hook this up to their existing support, and took them on the order of a day or two. Not exactly a huge investment to add some nice multi-touch support. The message itself is relatively simple, and we'll talk about some of the APIs that unpack gesture info structs and so forth. There are some subtleties here that we should talk about. The first is compound gestures. You can do something like start doing a two-finger pan and then decide that, you want to zoom in on that content. So you're in a map and you're panning down and you want to zoom in on Seattle. From our point of view, we call this a compound gesture. It's something that starts as one gesture and sort of transitions to another. In the set of messages you receive, you'll also see that. It will start giving you pan information, and it may transition to a zoom gesture during that. Coalescing. These messages are coalesced by user 32 for you. You don't have to do anything crazy like peek through the message queue and find the most recent one. The flip side of that is you are responsible for pumping your message pump reasonably fast if you want a lot of updates on the current state of the gesture. These messages also bubble up the parent chain. So if you have something like IE that's basically a frame with a bunch of hosted stuff under it that you may or may not control, if somebody does a zoom gesture over some child HWin that isn't yours, maybe it's some control you aggregate, and it doesn't respond to gestures, The gesture notification will bubble up the parent window chain until it finds either a window that handles it or sort of falls off the parent window chain, at which point the OS says, oh, this must be a legacy application that isn't aware of gestures, and we trigger our default gesture handling in that case. So we'll go and look for scroll bars that we can control. In the case of a pan gesture, we may send something like control scroll wheel if it was a zoom, that sort of thing. On the capture front, WM gesture command and gestures generally are greedy. So you could start a gesture over one window and then extend outside of it, and it still all gets sent to the same window. You don't have to worry about the messages not being captured. Quick and dirty overview of the supporting APIs. Get gesture command info helpfully unpacks the window message for you, and we'll show you the use of this in a little sample app. But the basic idea is you pass the W and L params that you receive in the window message into this API. It hands you back a gesture info struct. The struct itself, you can see in the lower half of the slide, has some information about the specific gesture command. Is it a zoom? Is it a pan? Is it something else? Arguments that are specific to that, so if it's something like a pan or a zoom, how far they're panning and zooming, and then the location that the gesture is centered over. Here's a handy-dandy little chart for interpreting gestures. You can see in the left column we have the different types of gestures, some of them. In the center, the kinds of arguments. So for zoom, pan, and rotate are sort of big three gestures. The arguments correspond to how far or how much the user is zooming, panning, and rotating. For most of the gestures, the location field corresponds to the center of the gesture, although for right-click, it will correspond to the first finger that comes down. Actually, let me back up and jump over to Visual Studio briefly and show you guys some of the code. Okay, so this is the sample app that I showed before, the little box that you can rotate, zoom, and pan in. Not surprisingly, we're starting in the WinProc here, and respond to some regular messages like WM size and WM command and so forth. When they get the gesture command, they hand it off to a little subclass that does its own processing. So we'll jump over to the gesture engine. First thing it does is allocate a gesture command info struct, clear it out, set the size of it, all pretty standard stuff for native development. And then we call get gesture command info. This basically takes the message that they were given, the parameters to it, and the struct, and unpacks it for you. And then there's basically a switch on the types of gestures you could get. If you get a zoom, if you get a pan, they do various things. If you get a rotate, they do some other stuff, so forth and so on. This is all pretty standard and pretty normal Win32 stuff. Let's go back to the slides. In a future build, probably one of the upcoming beta builds, there will be a minor change to this. So if you go off and start doing some work, we want to be level with you and let you know that there will be a small breaking change coming. Basically, there's some naming changes. Gesture command is sort of this unwieldy Baroque name. It's a little more complicated than it needs to be, so we just simplified things down to WM gesture. All the supporting APIs also are gesture info, get gesture info, that sort of thing. We've also added some fields to the gesture info struct. It has information about the source HWin that received the gesture and a bunch of other stuff that, as our clients started using these APIs, we found that was extremely helpful for them. We've also added some new support. You can configure how gestures behave over your window using the set and get gesture config and the gesture config structs. The basic idea is you could statically go in and say, you know what, rotate doesn't make any sense in my app. I never want to receive a rotation gesture. I know it's wrong. The user's only going to be doing zoom and pans over here. You might do it for recognition accuracy. Maybe you've got some custom gesture in your app that kind of looks like a rotate and you just want to turn rotation off. Maybe you've got some other reason for it. You can use set and get gesture config and say, for panning, I want these set of behaviors. And I can talk with you more afterwards if you're interested in the details. But just as an FYI, there is some new support coming. Also, if you want to set these things dynamically before every gesture, you get a WM gesture notify, which is your opportunity to, in a dynamic manner, call, set, and get gesture config to tweak how your window's behaving. Maybe the user has just tapped on, you have a painting app or something, they've tapped on the spray paint tool or something like that, and it makes sense to configure your gestures differently in this case. Maybe you don't want any gestures. You could turn them all off in that case. Single finger panning. I showed you this before. 2 fingers, always pan. But in the single finger case, sometimes touch acts like a mouse and sometimes it doesn't. Sometimes it pans. We have a heuristic for determining whether the user intends to pan or not. You can control this in your app. For example, if you have something like a mapping app and you always want 2D panning, you can set that up. Again, using set gesture config, you can specify for the GC pan gesture that you want these flags, the vertical and horizontal panning flags. If you're an application that, for example, never has a horizontal scroll bar and you only scroll vertically, you could explicitly say, I only want single finger panning to work horizontally. Or maybe you don't have scroll bars, but you have pannable content anyway. Lots of mapping apps are like this. You can specify exactly how you want single finger panning to work in your app to make it work the way you think it should. If you aren't getting the single finger panning default, and that's something you want, again, this is a heuristic, so there are some cases where your app behaves differently than we expect. There's a couple things to look at. One is use the standard scroll bars. We know that we can detect these and find these in Windows, so the common control scroll bar, MFC scroll bars, that sort of thing. If you're using a custom scroll bar that you've written yourself that doesn't pay attention to the SPM get scroll info protocol, or is windowless, or some strange combination of all of these things, we won't be able to find it, we won't be able to drive it, and we can't provide legacy support for you. So there's sort of a tier of things you could do here. You could just use standard scroll bars, you could respond to the SPM get scroll info protocol, or if you want, you can just implement WM gesture support and handle panning messages yourself. That's if you're having performance issues or latency detecting gestures, that's also a great way to overcome those. So another quick demo. Let's talk about WM Touch. WM Touch is a raw data delivery mechanism. In a lot of ways, it's similar to mouse messages. Let me pull up an app here. This is also one of the samples that's available in the SDK and I think in the hands-on lab. And it's a very simple scratchpad. It's basically a simple remake of Paint, and it just draws different fingers in different colors. So as I come down, I get different colors and so forth. This is pretty simple. You could imagine Paint using something like this. Paint actually used a different one of our APIs because they also wanted ink support in the future. But they could have very easily built on top of WM Touch. And we'll talk a little bit about how this was built and look at the code in a second. So as I was saying, WM Touch is a lot like the mouse messages. There's a WM Touch down, a WM Touch move, a WM Touch up notification. This is also one of the first entries in what we would consider the best bucket. It's really a foundational layer for building great touch-optimized experiences. It gives you the raw data off the digitizer. You basically get triplets of X, Y position of every contact and then a contact ID. And you can do whatever you want to do with these. You could build some custom gesturing application. For example, if the user taps with 4 fingers, maybe that does something natural in your app, like crop the photo or go full screen or close the app, something along those lines. Finger painting, like I showed before, and it's also, as I was saying, a foundational layer for a lot of the high-level touch controls. We use this to feed the manipulations and inertia APIs, which we'll talk about in a sec. On some of the more subtle aspects, again, WM Touch is coalesced. If you don't want it to be coalesced, there is a flag you can pass. WM Touch is an opt-in mechanism. You need to tell us that you want these messages coming to your application. When you do that via register touch window, there's a flag you can specify that says to turn coalescing on or off. So maybe you do want the full data, and you might not be able to pump your message pump that fast, but you're going to do something with it. Then on the capture front, WM Touch right now is greedy. That may change in the future, but for right now, if there is a single WM Touch window, it receives all the touch contacts once one is down. So The supporting APIs are pretty simple around here. Register touch window, like I was saying before, is the opt-in mechanism. This is how you specify that you want to receive touch data. Get touch input info is the unpacking approach. You get from the WM Touch messages, you pass in the handle, and then it hands you a set of contacts, these touch input structs, and you get an array of these. And then you can see here in the struct itself, there's things like the position, the ID of it, the various other things like extra info that are similar to what the mouse message has. And then important, you also have to close these handles. If you don't handle WM Touch, DefWinProc will handle it for you, but if you do handle it, it is your responsibility to close the handle. Let's look at code briefly so you can see what we're talking about. Oops, wrong one. So this is the Scratchpad app. And again, we are in the WinProc, as you can see, and they're handling WM Touch down, touch move, and touch up very similarly. There are some subtle differences between these. For example, touch down and touch up will never contain a notification of the other type. So you have these array of updates about contacts. You'd never get a contact going up, for example, on a WM Touch down message. The first thing you can see is that they basically allocate an array of touch input based on the number of contacts which come in the W param. And then they pass that array to get touch input info, which basically hands them back this unpacked array of touch input structs, which then they can walk through and do something interesting. So in the case of the Scratchpad app, it's pretty simple. They've got some very basic handlers that, on a down or a move, draw the pixel on the screen, and then when the fingers go up, they stop tracking those contacts. And they basically walk through the set of contacts and update them. And then they close the input handle, as we need to do. So back to WM Touch. Again, in the beta build, you will see one small change here. We're consolidating all of these messages down to a single one. A lot of the people who are consuming WM Touch did what we saw in that sample, which is basically have a switch statement where all three messages fell through and they handled them all the same. They weren't really interested in the sort of subtle distinctions of what types of state changes you'd see in each message. They just wanted to handle any possibility of any state change in a message. So we're going to simplify WM Touch down to just one single message and give you ups, downs, and moves in that array of touch inputs. Okay, time for one more set of demos. Thanks. And we'll come back to our little globe app here. I want to show you a couple things you may not have picked up on the first time. The first is, let's pull up this little control here, and let's also do a quick search for location. So if we search for Seattle, we'll go diving in, and we can pull up a little info card about this. And one of the things you can see here is that I can interact with both of these at the same time. And both of these support different things. This little card, I can rotate it. Yeah, there we go. I can rotate it and move it around. And I can do the same thing here with this little control panel that lets me do things like turn on the 3D models and change the viewing angle. This is a great example of what we call manipulations. You can interact with an arbitrary number of objects with an arbitrary number of fingers in each object. You're not really constrained by some of the things that you have in Windows today. Like Windows is very much about one point of focus, one active application. We're breaking a lot of those things with the manipulation model. It's very easy to have multiple users or a single user interacting with multiple things at once. I can also do things like interact with the map at the same time that I'm using these controls. Like I can move the control and move the map around separately. So that's one of the key things about manipulations. Manipulations are really a superset of gestures in a lot of ways too. Let's go to the next slide. when we're talking about gestures, gestures are really a sort of simple way of getting into multi-touch. Manipulations are squarely in the best bucket. These are used to build really great experiences, this API, and paired up with inertia. The sets of things that you can do with manipulations are really a superset of what you can do with gestures. For example, with gesture command, you can't rotate and zoom at the same time. That's not one of the sort of allowable actions. But with manipulations, you can do the full set of 2D affine transforms, translate, scale, rotation, all at the same time. Like you saw before when we were playing with the map, it's very easy to rotate, move, and zoom in all at the same time. We support concurrent manipulations. So if you have a photo app and you want to be able to have users grab however many photos they can get their fingers on, manipulations is a great way to do that. If your hardware supports that many people interacting with it, there's nothing that stops you from creating a different manipulation processor for every photo and looking at the contacts that you see and then updating the photos appropriately. Manipulations needs a source of raw data. Like we were saying before, WM Touch is sort of foundational for a lot of higher level controls and APIs. You can feed it with WM Touch, or you can use real-time stylus, one of the tablet controls that also supports multi-touch, or whatever other source of multi-touch data you have. Maybe you've cooked up something, your own multi-touch sensor, and you have your own proprietary API. You can push that data into manipulations. We just need contact IDs and positions, basically. In a lot of ways, these are similar to the Surface APIs, too. So if you're familiar with the Surface SDK, if you've done Surface development before, it should be very easy to use the COM or managed manipulations APIs that Win7 provides. I'm not going to jump into the interfaces because they are relatively large, but for future reference, iManipulation Processor and iManipulation Events are the two that you're interested in. The basic usage model for the processor is as contacts come down, you add them to the appropriate processor and do your own hit testing. So again, if we were talking about something like a photo app and you have two photos, if I put a finger down and it's on one of the photos, you've done some hit testing, you figure that out, you add that contact ID to that manipulation processor for that photo, and then it will track that contact over time. And maybe a second finger comes down and the user's starting to do something like a zoom. You've added that second finger to the manipulation processor. It's now watching both contacts, and it will spit out updates of the transform matrix that you can then apply to your photo and zoom it as the user zooms, rotate, that sort of thing. And again, you can have multiple manipulation processors. So if you have two users, each trying to zoom their photo, well, the manipulation processor for the left photo is paying attention to two contacts. The manipulation processor for the right photo is paying attention for two contacts, and you're getting different transform matrices from these. And that comes back through the iManipulation Events interface, which will tell you information about the types of manipulations the user's performing. And then when those fingers come up, when they're done interacting with the display, you can remove those contacts on the processor and we'll stop watching for them. Inertia is designed to work hand in hand with manipulations. It provides a very, very basic physics model. Basically, you saw in the globe how we could spin it, or when we were doing something like panning, how the content continued to pan. I'm sure somebody will write a better physics model that has ragdoll physics and inverse kinematics and all sorts of other things. But that's not what we're shooting for here. We're thinking about the sort of common interactions that make sense for Windows apps broadly. It uses the same event interface as manipulation. So if you're already using manipulations, you can continue to receive updates from inertia. So if instead of zooming those photos, the user was dragging them and sort of lets go, if they've passed some threshold that it triggers inertia, then you will continue to receive new affine transforms via iManipulation events as it sort of coasts along. The inertia processor you can set up in various ways too. You can specify how much friction you want or how far you want the inertia to carry the object. There's two different ways to specify it. And we support all sorts of inertia, everything from rotational inertia to translation and scalar inertia as well.
So I know a lot of you are managed developers, and Windows 7 provides really good kind of foundational support for native code as well as for us to build upon it. And in WPF 4.0, we are building this support in with the WPF programming model. And I'd like to kind of go through what that looks like and what type of stuff that you will be able to do in WPF in the next few slides. So multi-touch in WPF. We're making a number of changes into our input system, into our base UI elements and UI 3D elements. For these base elements, we're adding support for gesture events, such as one pan, zoom, and rotate that you've seen before. Touch events, which gives you the raw input, and new devices, so you can recognize that the various touch events come from different contact points that you have on the screen. And we are also making changes into the base controls themselves. So WPF is not based on HWin, so we don't get for free some of the enhancements that the base OS has made. So we're going to have to make some changes in our controls in order for WPF applications to get this for free. So we're making updates to the scroll viewer so that we can support panning without you having to incorporate that into your own controls. We're also making a lot of base controls multi-touch aware. So, for example, if you have a button on the screen and you touch it with 2 fingers, you really don't want the click event until both of them are out. Both fingers are released. So that type of changes we're going to make throughout our platform. We're going to support multiple capture. Reed showed you how you can use 2 fingers to operate multiple controls on the screen together. We're going to support the equivalent of that so that you can have multiple active controls. For example, you might want to implement a on-screen keyboard where your Shift A, you can kind of press both of those together. Or you're implementing a audio mixer where with multiple fingers you can operate the sliders concurrently. So that will be built into our platform. We're also going to look at new multi-touch specific controls. We're working closely with Surface, as I mentioned before, to see which controls actually make sense to bring down for everybody. We don't have specifics for that. We'll have more information on that as our plans solidify. And more importantly, we want this infrastructure to be compatible with Surface. And going forward, we expect that you'll be able to take applications and controls that you write on Windows 7, be able to move these over to Surface with little or no changes. And you can also light up on Surface if you want to get more information from the Surface Vision System, for example, and have a better experience for your mapping control, for example, on Surface than it is on a device that doesn't provide as much information with your touch contacts. So let's take a look at an application, WPF. WPF is vector-based rendering. So in many ways, it's really set up very well to support multi-touch because you can do the types of manipulation, rotation very easily within the platform. So here's an application that we built. In fact, we're going to make this source code available in the next couple of weeks. This is a simple photo browser application that we have that we've built with WPF. You can see that with you can see that we in WPF we can provide multiple themes depending on. If I can get my scroll bar, go back to the home. You can see that we can set up different themes for the application based on the layout and the size of the window. And this works very well. So you can see if I maximize the window, I provide more information. And one of the themes that we added is a touch theme. And with the touch theme, it's really optimized for using manipulations and the screen is not responding right now, but let me start that up again. That's what happens when you're presenting on software that you're just currently building. There we go. So you can see how with touch, you can you can have very good user experience for sorting photos, etc. So next step, let's take a look at what it means to build an application such as this. So the first thing is, in the beta bucket, we have gestures. So in WPF, we base our gestures on the manipulation processes. So you get your 3 types of transformation all at the same time. You get your zoom, you get your pan, and you get your rotate at the same time. And this is available to all UI element and UI element 3D based elements. They're not routed in WPF. We don't tunnel the gestures through in order to support the multi-capture capability, so that different elements can capture their own set of gestures. We also make this really easy to enable inertia into the gesture. So when you get the gesture started event, you can go and say, hey, I want to enable inertia, and you will be getting continual gesture change until the inertial movement finishes. And if you want to further configure what the starting inertia, what the starting rotation is, you have an opportunity to do that with another message. So let's take a look at what it takes to implement applications such as this. I just realized I didn't show my slide. Okay. So let me switch over to a coding demo here. All right. So I've written a very simple demo to illustrate how to use gestures. So in this case, I have a window that has basically a canvas on, and I have written a simple user control. That's a photo control that basically hosts an image element. And you can see from the XAML, it's very simple. And I wrote a little bit of code that populates the canvas with the photos that it read from a photo directory. So we just run the application. You can see it's just a collection of photographs. So now what I want to do is to incorporate gesture into this application. So in the code behind file for the photo control, I start by setting up the render transformation of the photo control. So this dot just basically an identity matrix. The next thing I'm going to do is I am going to add the handlers for the gesture events. And I only really care about 2 of them at this point, which is the starting and the change event. So touch, gesture, started. Let me do the automatic. There we go. And I'll do the same for the touch change event. So when I start, I'm going to make a copy of the render transformation so that I can make use of that later. So the original matrix equals to copy of the matrix. And mark the event as handled. So let's take a look at the event itself. So this is basically a simple touch event. Touch gesture event. And if we go to the touch change event, you see the parameters that we provide. You get the original position of your gesture. You also get information such as the rotation, scale, and translation. And, and in the full implementation, you also get kind of the deltas for these things as well. So for the, in order to actually implement the gesture itself, we're basically changing the render transformation. And we can do this very simply by using a helper method that is on the event arguments. Calculate transformation matrix, and I pass in the original matrix. I'm also going to make sure that I handle this as well. So just by essentially that few lines of code, I can respond to gestures, and because we have render transformation, and it's very easy for you to implement these type of functionality in your WPF applications. So touch events are the raw multi-touch input events, and these are routed events, and they also have preview variants. Unlike the gestures. So you have touch down, touch move, touch up, equivalent of what Windows has. And we also support multiple capture by having a new set of methods on the devices where you can capture individual contacts as well as finding out what are all the captured devices within an element. And let's take a look at what it takes to make use of these methods. So let's run a fun application we have here. So this application basically puts a media element on top of a grid, and we added some physics support there. So you can see that I can grab a corner and kind of swing around the cloth, and as you have multi-touch, you can actually manipulate a cloth very similar to a real physical object. So I can kind of sling it off like that. And the code itself, the physics part is somewhat complicated, but the touch part is actually very simple. So we can take a look at what it takes to actually make use of those events. So in this application, we have this cloth window. And we initialize the viewport, all the 3D support in order to show the cloth in 3D view. We have built we're using a visual brush for the surface of the cloth, and we put a media element there. You can, in fact, put a button in or any other WPF element as well. We're setting up the physics loop during the render target, so this gets called back on every frame update, and then we're hooking up the touch events. So in this case, when we have the touch down event, what we're doing is we're capturing that particular device, we're marking it handled, and we're stashing it away in a simple dictionary so that we can use it, so we'll know when during the touch move which particular contact that we're working with. In this case, we're calling the cloth is a class that implements the cloth, and we're basically passing this contact to the cloth. And the contact class basically is a very simple class that we wrote that stashes the start position and it calculates the delta as you go. So this is entirely application code. And on the move, I'm pulling out the contact from my dictionary so that I know which particular one is being changed, and pass that to the cloth object. I'm basically doing the equivalent of that in the touch up, and then I release the capture for that device. So you notice that this is very similar to what you would implement in terms of for your mouse handlers as well as your stylus handlers. So in WPF, we really modeled the touch events to the stylus events because they're really very similar. And we promote touch to stylus and then stylus to mouse if they're not handled. One of the consequences of this particular design is that you can actually have use stylus and touch together. So I can imagine implementing a painting application where the stylus would be used for actually painting on your canvas surface, and then you can use your left hand or your right hand can be used to recognize gestures so that you can zoom and pan while you're painting as well. So this type of interaction, of combining like touch and stylus, I think will be very powerful as we see more devices support this touch. So let me hand back to Reed, and he'll talk more about the tablet enhancement supports.
There you go. Very briefly, if folks are familiar with the tablet platform, Real-Time Stylus has been updated to support multi-touch. So if you've got an inking app or something like that, it's very easy to add multi-touch support. By default, you get gestures over RTS. So if you actually want multi-touch inking, you need to use iRealTime Stylus 3 multi-touch enabled and turn it on. In Ink Collector, it's a little more complicated. You have to set a window prop. We've got a little example here that shows you how to do it. But this takes us to the UX considerations. Running a touch app is not just what APIs you use, but also how the user interacts with it. And you can see down in the corner here, we've got a little snippet of the ribbon. And the ribbon shows some good things and some areas that might be a little hard to use with touch. For example, the spell check button there is something that would be very easy to hit with touch. There's common sense things, like targets need to be fundamentally large enough for you to tap on them. White space between controls is very important too. If you have, print my document right next to delete and nuke it off my hard drive, well, that's going to be frustrating for the user who misses ever so slightly the print button. Things like hover are also difficult with touch. Most touch screens today, this may change in the future, but today don't support hover. They don't get any contact information until your finger actually is in contact with the device, unlike the mouse or pen. So things like a web page where you have some, navigation hierarchy that flies out on hover, things like that are very difficult to use. Some other stuff about the ribbon here, it does a great job of pulling to the forefront the tasks that are common. And this gets back to what we were talking about before with touch, where not everything needs to be touchable. It probably doesn't matter that, translate or some of these other little micro buttons are small because they're not things that the user is going to do a lot with touch. They may want to do spell check because they're about to review their document before they're running to a meeting or something like that. The tasks that are important for touch, could have large buttons and be brought to the forefront. And then very quickly, since we want to have some time for questions, on the hardware side, be aware of hardware. Like we said before, there's a huge a huge array of form factors that support touch, everything from little tiny mobile phones to laptops to all-in-ones to Surface. Think about how your UI will look on these different things. If you go down to a little 12-inch laptop, is it cramped and the user can't tap on things? Again, hover falls in that bucket. And then for gestures, if you are building your own gestures, make sure they map to something useful. Putting 4 fingers in your nose on the screen and drawing a W to launch the web browser of your choice is not something that anybody's ever going to remember, and it's not useful. But something like Zoom, where they grab the edges of a photo and stretch it, that's perfectly natural and intuitive for users. So keep that in mind if you are building your own gestures, and use the common gestures where you can. So we worked with a lot of people for PDC. Autodesk, Evoco Secure, Corel, Cyberlink, Fuel Industries, Identity Sonic. You can see a lot of these demos and applications in the pavilion. I'd encourage you to go check them out if you haven't. A couple things while we were working with these folks, it was very easy and straightforward. Almost all these demos were built in a small number of weeks. Nothing about the APIs is immensely complicated. If you are interested, feel free to email wintouch@microsoft.com with questions. And let's come back to the call to action. We've talked a little bit about this at the beginning, but bringing it all sort of full circle. what we'd really recommend is think about in your app, your app does a lot of different things, or maybe you're building a new app. What are the things that make sense to do with touch? For those things, think about what set of investments. Is it something that needs to be a touch-optimized experience? Is it something that makes sense to use our legacy support? Is merely adding gesture support to your existing app the right way to go? And then go off and make it happen. Let's build something amazing. I really can't wait to see what this community of developers is going to put together. It's going to be truly amazing. So, before you run out the door and get started madly coding, what do you need? On the hardware front, you need a device that supports touch or multi-touch. Things that are available today that support multi-touch, the HP TouchSmart 2 up here, or the Dell Latitude XT, which Anson's using. Both of these have beta drivers that are available that enable multi-touch on them. You can get these off their websites. I can also give you the URLs afterwards. On the software side, you need the pre-beta build that's on your hard drive. We had a little snafu with getting our samples and documents into the SDK that's in there. They are in the folder, the portions of the SDK and the samples are in the folder with our white papers, I believe, on touch and multi-touch. They're not actually in the platform SDK itself yet. We'll get that fixed for the next release of it, which should be coming soon. And then for WPF, the 4.0 release will be before the end of 2009. And do I talk a little bit about 3.5?
We will be hoping to get this into the beta, first beta build that you have. It's not currently in the CTP for that's on your hard drive today.
So additional resources. The WPF roadmap talk, I think Kevin Jersted's.
We had that yesterday.
Yeah.
Yeah.
You can watch that later if you haven't seen it already. That's a good one. Developing for Microsoft Surface, that's also one we'd recommend. The hands-on lab, as we were talking about, down in the pavilion area. Feel free to get in there and get your hands dirty playing with these APIs. We have a white paper that's mostly UX topic focused. We will be in the product pavilion and at Ask the Experts tonight and in the track lounge. You've got lots of opportunities to ask questions and find us. And then you can always send us mail at wintouch@microsoft.com as well if you don't get your questions answered while you're here.
And don't forget to play on the Surface tables.
Yes. All right, questions?
Yes. What are the different types of touch hardware? I understand there is like 2-finger, 10-finger.
So there's a broad range of hardware right now. There's a lot of different technologies, everything from capacitive to resistive to various optical technologies, and they tend to support different numbers of contacts and things like that. Like a lot of the optical solutions, for example, support 2 contacts now. There's nothing that technically prevents them from supporting more, but for various reasons, the hardware that will be available either today or at Win 7 launch will likely support 2. A lot of the capacitive devices may support more, say 5 to 10 fingers. Long term, I think you'll see that some of the distinctions disappear and there's more of a blending of the various technologies, but right now there are some things that are specific to various technologies. Does that answer your question? Cool.
Would there be any kind of helper support for pop-up touch keyboards or anything like that?
So the tablet keyboard, the tablet input panel, has a keyboard skin, and if you open the tip with touch, it jumps to that skin and comes out larger than if you're using some other input method like the stylus. We are still looking at whether or not we'll support multi-touch on the keyboard. We'd like to, but no promises.
Okay, thanks.
I've had the fortune of co-founding 2 companies, and I've been working in touchscreen technologies for over 15 years. And more importantly, recently, I've had an opportunity to work on the Surface platform, developing an application. I sense what you guys are working on here is a bit of an overlap, and I also sense that you're recreating some of the stuff that it appears these guys have been working on for 3 years. And I'm hoping to see a little bit more of what these guys have created in what you guys are working on as well. Are there some plans to?
So from a WPF perspective, we're working very closely with Surface to make sure we have a really good migration path and we can, as I mentioned earlier, our goal is to make sure that what we build on WPF, if you're building against Windows 7, can move over to Surface. So we're working very closely with Surface, and we want to have a really good roadmap.
It's great to hear their SDK is a phenomenal experience for developers.
Yeah,
so
absolutely,
I hope that it carries across.
I was interested, is there going to be a story for multi-touch support in Vista at all? Because y'all all are supporting WPF 3.5. And I'm also interested in what is the multi-touch story going to be for embedded devices, both Vista embedded and Quebec?
So from a WPF perspective, WPF 4 will go down level in Vista. We will actually have a extensible input mechanism. So when there is actually multi-touch input, one could plumb through the same mechanism for the platforms that we support.
But you have to write your own input
But you
provider.
have, in that case, you have to write your own input provider.
From the operating system side, I wouldn't count on seeing Vista support for multi-touch. We generally don't backport large features like that.
What about embedded?
That's a good question. I don't know all the plans of the embedded group. We have been working closely with the Windows Mobile guys. I can't answer that right now.
What about plans for support for Silverlight?
So we're working very closely with Silverlight. I don't think they are ready to announce any specific support. We've been working with them in terms of gestures. So
I'm a bit confused about the WPF as it is today.
Mm-hmm.
Is there any capability, if I get a Touch Smart 2,
right.
what can I do with it,
So
with Vista?
on Windows 7, with WPF 3.5 SP1, through the stylus messages, stylus events, you'll be able to get at the multi-touch input. And you can also make use of the manipulation processor and inertia processor to apply, gestures or transformations, based on those input.
That's all through API calls. That's the only ability.
Well, the stylus event, stylus up, stylus down. If you go, so with 3.5 SP1, you have to go and enable multi-touch input at the window level. That's a window property you have to set. And then once you have that, then your stylus input will actually give you the multi-touch information, and through that, or the ink collector, or the real-time stylus stuff, you can have multi-touch support. It's just not built into the framework as I've shown you there.
And that's Windows 7
I'd say there's two
only.
paths. I mean, Anson described one option. There's also the interop option. If you're comfortable with interop, you can interop to all the native stuff and use WM Touch to feed some higher level API. And then the prior to .NET 4.0, the manipulations and inertia controls are available with a managed wrapper. So you could use those from real-time stylus or some other raw data source.
Yeah, the only caveat about the WM messages, you can hook those and make use of those. Except in WPF, we only have one window. So there's going to be limitations in terms of WM Touch and WM Gestures messages together. So.
Yeah.
Can I run a Surface app on that HP Touch Smart device?
Not currently.
Not currently. So how the Surface apps are sort of tied to the Surface?
So Surface has an SDK that allows you to cross-develop on non-Surface, on machines that's not Surface tables. There is no story currently on running Surface applications on any devices other than the Surface table.
I'd encourage you to talk to the Surface folks. They are here at PDC and have a great presence. You can ask them questions about that too.
Is there a limit on how many touches it can support simultaneously?
No, the platform is not limited. You're more likely to be limited by the hardware itself. For example, the Touch Smart here supports 2 contacts. The Dell XT supports a much larger number. I don't think they've finalized the total number, but somewhere around 5 or 10, something like that. So the platform is basically hardware agnostic. We will see how many contacts the hardware is passing us, and we'll pass those up to client apps. So if you have something like finger painting, you can report however many fingers are coming back from the device. If you're writing something like a game, you could query, it takes 2 fingers to play as a single person in your game. You could query how many contacts the hardware supports, and then light up the right number of players or something like that.
if there is a hardware that can support, for example, the Surface project, they support two types of touches. One is the fingers, and another one is the blobs. So they have different types of touches. Can this Windows 7 support that?
We don't have the same notion of a blob. Because we have a lot of scenarios that use touch and pen together, we're very worried about things like palm rejection. You wouldn't, in an inking app, want to be inking and then have your palm leave little palm turds as you go along. So for things that are very clearly not pointing touches, our palm rejection heuristics mask those out. So we don't have the same notion of a blob, which is generally sort of a large amorphous contact.
On WPF, depending on your input provider, we have extensive mechanism to provide more information than just the position and size of your contacts. So that's how we accommodate Surface.
Thank you.
So 2 questions. First one is, I didn't catch, do you support multiple windows with multi-touch or just a single full screen window?
What do you mean? Can you be more detailed? There are some limitations. You can't, gesture in 2 windows simultaneously. If you were using, as a general rule, let's say no. You can't have multiple input yet in multiple windows. We are somewhat constrained by, the Windows notions of focus and active applications and things like that. So that may change down the road, but for now, you have one active app receiving touch data.
Okay, thanks. Second one is just, do you support finger orientation?
There are, from our point of view, the device is just a HID device, right? And there are usages in HID where you could express things like rotation. We don't do anything with them at the OS level feature-wise. We don't treat a rotated finger differently in a rotation or a zoom or something like that. You could write an application that requested those properties and did something with it if you also had hardware that provided it, but it's not something that we require the hardware to provide to get a logo, for example.
Okay, thanks.
What is the expected quality of reliability of gestures? Is it going to be foolproof? What is it now in W7? What will it be in the future?
Well, I'd encourage you to come to the pavilion or come up afterwards and play with the unit and see for yourself if it meets your bar. We have spent a lot of time tuning the gestures, and we're still doing this. Our basic process is we collect, 1,000 samples from users about how they do zooms and, pans and this sort of thing on various size targets. And then we basically data mine all the resultant data, and we tune the gesture algorithms and the parameters in the gesture algorithms to maximize the success for that user base on those sets of gestures. So we look very closely at tuning them. I certainly hope you feel that they are natural and intuitive and you don't have any sort of gesture misrecognition problems. But again, the proof's in the pudding, so you should come play with the pre-beta build and see how you feel about it.
Just wanted a little more clarity on the Surface SDK and the Windows 7 touch support.
Yep.
Surface SDK has things like scatter view, surface button, a lot of WPF constructs. It relates specifically to WPF support, not the native. So will the Surface controls be supported in WPF 4.0 on Windows 7?
So we're working closely with the Surface team to make, to actually figure out, for example, scatter view may end up, as a base platform available to everybody. We're still working through that process and figuring out what actually makes sense. The goal is, if you were to write in WPF4 with multi-touch, you'd be able to move those things and work on Surface with, with little or no modification at all. That's definitely the goal.
Okay, so the opposite way wouldn't work? So if I have a whole bunch of Surface apps?
Again, it's a subset, superset issue here.
Okay.
Obviously, if you make use of if you're writing things, making use of Surface SDK, we don't have a clear story about whether that's going, that'll be on Windows 7. I think you should talk to the Surface team to give them feedback, and we'll figure out what the story is there. But we're definitely very much committed to a direction where, with the subset of capabilities that you can get on Windows 7 with respect to touch, you'll be able to move those things over to Surface. Like your feedback and your scenarios on these things will be very useful for us. So,
Thank you. We probably have time for just 2 more quick questions before we need to move to the lounge. We don't want to delay the other talks.
Sorry, it's a couple quick questions. First, just to make sure I got that, when you're responding to the touch events, it sends back a collection of structures for each point, and each structure has an ID to track which.
Yeah, so if we're talking about WM Touch, you basically get an array of touch input info structs, and each of those has things like the position and a contact ID. So if I've got 3 fingers down, you'd get 3 entries worth of
And it's a contact
position.
ID that tracks.
Yes, and the contact ID is persistent while that finger is detected by the device. So it's not going to change under you or anything like that.
The second one was when you register a touch window, does it still receive gesture commands?
Good question. Not today. We may look at changing this in the future, but there are some scenarios where they would conflict, like if you wanted to do your own custom gestures and you wanted to re-implement Zoom or something like that. So for today, there is no way to both make use of our gesture detection and get the raw data. So you have to pick one or the other.
WPF is similar. If you handle the touch events, you won't get the gestures, but you can preview the touch if you wanted to, for example.
For companies who are already producing our own touch-capable hardware, are you planning any technical support for writing their own drivers? Or maybe you're planning to supply generic drivers?
Good question. The driver interface is something we'll talk a lot about at WinHack next week. So if you can stay in LA for a few more days, you should come to WinHack. We have a white paper that talks about how to write a nice multi-touch driver. We have samples in the WDK and a bunch of other stuff. I can point you to those later if you want to meet up afterwards. But yes, we do have content for people who want to get their hardware working and talking to Windows 7. I think that's probably all the questions we have time for. We will be in the pavilion, and you can ask us more questions there. Thank you very much. And don't forget to fill out your evaluations.